first of all, if you cannot find your name from the list over here, so which means you missed the case 1, selection of database. Right now I have 17 students, 17 databases. But we have the 21 students, so still 4 students didn't submit and didn't get the approval of me. So which means it will be 0 mark for the phase 1. So phase 2 is due on the October 5th, this Friday. You need to submit the survey, the research of your selected database using the given format. It's item3 or the ACM, the 2-column format. It's for your practice. You don't have to be too much serious to follow, but for your practice and experience to use technical form. So please, you can use such a 2-column format to write your research. Then, this is more important thing. Next week will be October 10th. So October 10th, we are going to have very short presentation for each student. So I think that you can prepare the 3 or 4, less than 5, the slide for each student. So please, you can. You need to submit the presentation file. So that presentation file less than 10 pages, but you will have only 3 minutes for each student. It will be kind of a lightning talk. So very quickly transit to the next student. Even though you cannot introduce all your research, it's just 3 minutes. I'm not sure whether 3 minutes is good enough, probably not, but sometimes the 3 minutes can change the entire human history. So please select, you don't have to spend a lot of time for introduction part, just very briefly introduce what is your selected database, what is the characteristic, and what is the benefit, what is the pros and cons, the disadvantage of that, okay? Then, so based on what you learn or what you survey or what you research on your selected database. So it's only 3 minutes. Within 3 minutes, you need to hook up me and the other student. Then I'm going to select right now I have the 21 students. So probably 11, 1 student may be alone. So I'm going to select the 10 selected, 11 selected the database. I'm going to select the 11 databases, so which means that these 11 students will be leader of each team. Then I'm going to assign the other 10 students for each team. So the rest of the part, the phase 3, the M4, the second part will be the group by the 2. So it will be group project because I expect less than 20 students, but eventually we have the late registration, so we have 21 students, so I'm going to form 10 or 11 group. Then you will implement your selected database, so then including the data, you need to collect the data. Sometimes you need to find the proper data set, like the document is for the JSON file or the something other, and the graph, you need to find the graph data, so like that. So, and also, you need to model such a selected data and collected data based on the characteristic of your selected database. Finally, you need to implement based on the model, create the database, and implement the program that would like to access your selected database using the given API. Sometimes it may be possible your selected database does not fully support such an API. At the time, with my approval, you can switch to the database, which was selected by your team members. Okay, so that means another team member will be the kind of backup database. So for future, okay, those who are selected will get the extra point as a leader of your team, okay? But my selection criteria is first your presentation. Your presentation should be impressive. And also the difficulty level of the database, selected database. Some of them are very generic, nothing special. Okay, and it has been used. But if very interesting and it's very challenging, you will get the extra point. Okay, and also I need to consider the balance of the different types of NoSQL database. So as you have, as I introduced before, it's a document database, a KV, the key and value database, and the graph database, the column-based database. So I try to balance. Nowadays we have the new SQL database as I introduced last time, so which means it supports the consistency as well as something the proper scalability. And also it has the kind of multi-model. So it supports not only the one, but it's a same other. So I'm going to balance. And also usually I try to select the database which I never see. Okay? So please think about such a thing during your presentation. So it's only 3 minutes, so you should be ready. Okay? I'm going to download all your submission to my laptop and to reduce the transition time. So I'm not going to allow to use your own laptop, so you can just use my laptop and use the PowerPoint. If you, so please submit either PDF file or PowerPoint. Freelancer or the other may not be available, but anyway, I'm using MacBook, so as long as the MacBook support your presentation file, it will be okay. Okay, any other? Midterm. I do not have an idea yet, so I usually have the one exam for the 600 level class, including NoSQL database. But if you're as I usually consider, the overall performance is not so good, then definitely we will have the final exam also. So midterm exam maybe after our presentation sometime. We need to do something progress on the lecture that cover the HBase and the other NoSQL database. So maybe early November we will have the very short midterm exam for your evaluation purpose. But you don't have too much serious. More important is the research on your selected database and the implementation. So it will be a very generic question, not the theoretical question, not the, too much practical, very generic question. So like what is the cat theorem, or what is a NoSQL database, and what is a KV, and something a little bit about the big data heading system. So a little bit very generic questions. So please pay attention to your project. Okay. Anyone? Your name is not here in this classroom. Did you submit? Did you get my approval?
Yes.
Why don't you forward my email or message that I approve? Then probably I miss the yours. Okay? Otherwise, you will not get any credit for the ace one. Okay. Any other question before we start? Okay. Today, before we discuss about the detail, I think that we have homework, right? The research on the spanner, right? In terms of cat theorem, so please submit your homework before the class end. So today's, before we start from the next class, we will talk about the one representative NoSQL database for each category. As I mentioned, the categories of the NoSQL database, type of NoSQL database, column-based, KV-based, document-based, graph-based, nowadays the multi-model, and the NoSQL database. We will select one very popular such a NoSQL database, including HBase, Cassandra, the MongoDB, and I'm thinking to add one more from the NoSQL data, the new SQL database. That is a spanner that you did the homework. So we try to practice with the spanner. You based on the GCP, the rest of the semester to do that. So before we start to discuss about such a details of the NoSQL database. Anyway, it is true, the NoSQL database is based on the relational database. due to the limitation of such a relational database, so we need something other database model and data model. So it is very important and helpful to understand the new NoSQL database if the based on the relational database, like the SQL database. It looks like even though you already took the advanced database design course, or some of you guys already took the database class in your old university, undergraduate, or even other graduate school, or some of you guys already studied by yourself the SQL relational database. Surprisingly, not many students, even the developer, even researcher, they don't know much about the really characteristic relational database. One of the reasons is it's too popular. Okay, so it looks like if I'm using the RDBMS, so I believe that those who are using the relational database, so practically they believe they know much about the internal or the theoretical part, fundamental part of the relational database. Actually, there are behind a lot of things going on. So most of the NoSQL database try to address the problem of such a relational database. So today, I'd like to summarize what you learned in your advanced or the database design course, whatever the database course. Mostly it's a semester long. Sometimes it's a 2 semester long. The courses, but within a week. So today's class we will talk about. But it's not only for the. I'm not going to introduce what is a SQL and how to use the select from where. No, instead I'd like to give or remind your concept of data and database using the relational database. Okay, so that is the purpose of today's lecture. So you can be a little bit relaxed, but think about when we talk about the component of the relational database, then you can also think about when you are writing the report for the research paper for your case 2, you can always compare with the relational database. For example, if your NoSQL database is pursuing the consistency, then how does the relational database keep the consistency? Then how the selected database keep the consistency with the partition tolerance, like the distributed system, something like that. Okay. Before that, do we need to use always the relational database or any database system in our for example, suppose that you are the manager of IT department of any company. So pretty much nowadays, most of the company they have the IT department or the IT manager or even the chief technology officer, CTO, something like that. At the time, it is true most of them use or utilize a database system, especially relational database system is popular. So do we need to use the database management system in our IT infrastructure or not? Depends on. Sometimes yes, but most of them yes. Really, that is true. And also it's very expensive and it's not easy to manage. So we need to hire the administrator for database. Then usually their salary is very high, and even though you hire the high salary, the administrator, but you realize that their experience is nothing. It's only for the specific domain. It's not working for my domain, something like that. So already many cases it's disappointed. So go back to the question. So do we need a database? When do we need a database? When we don't need such a database? Large amount of data, that's critical. So what if we have a small amount of data? That doesn't mean that such a small amount of data is not important. No, still is very important. And also we need to access such a data. However, if we have the small amount of data, then how can we manage such a data? consistency or the read or consistency or availability. How can we manage such a small amount of data without the DBMS? We can use Excel. That's one. So like your personal information. So anyone who are using the relational database for your personal purpose? Probably not. Even I think the Radisson, what is the name of the CEO of the Oracle? He may not use, right? For personal purpose. Nobody uses the Oracle database or any other DBMS for personal purpose. Maybe. Very rarely use it intentionally. But the most of the case, not. Instead, as he answered, like I'm using, I do not use even Excel. I'm using text file. So all the contact list is in the text file. That is the fastest way, really. Always open and the Control F search. Then I know where are they. Usually, page down the 3 times I can find the parent's address or something, my friend. So even though it has more than the 200 contact list, I know that because that is the fastest way. So I don't have to use even the Excel. So Excel is expensive to buy and to open, it takes time. Instead, the TXT file, Notepad is enough. So that's the way of the trade-off, using the database management system or not. So in other words, so we need to think about what is the main purpose of using the data and the database. What is the main purpose? If you already took my course, so we discussed a lot. Search. That is the ultimate goal of computer. Because think about any functionality, any reason, any purpose, objective of computer. Why do we need use such a computer system? To search the data, to search the specific information. At that time, what about the calculation? Like the calculator, old-fashioned calculator, Leibniz calculator, even non-electronic the calculator. It's also search. The answer, okay? It is based on the equation, include the computation. Finally, output is the value. So we'd like to get the 1 plus 2 is equal to 3. We'd like to get such a data. We'd like to search such a data based on the equation. So we can regard all the functionality as the search or sometimes query. We will talk about what is the difference between the search and the query. But that's our goal of using computer system. If that is true, it can be a little bit controversial, but if that is true, should be fast, right? If that searching is slow, in other words, that computation is slow, then you can just throw away. So database is the same thing. Considering your environment. So first criteria when you select the database is should be fast. Okay? Then you can consider consistency. You can consider availability. Or sometimes management issue. How much is it? And something like that. Always it should be fast. That is the same thing in any computer and computer application. If computer is slow, nobody uses. Okay? If computer does not provide response time, so you don't have to use it. So that is our goal of that. Then, is database fast enough or not? So I asked why, when we not to use the database, this small amount. Usually when we have the small amount of data, so using database is fast or slow? It's still fast. Actually, using database, what is the database management system? It's a software, right? It requires a lot of additional things in our system. Let's go back to, we are using the DBMS approach, database or database. So versus non-database DBS, DBMS, MS. Okay. In other words, it's a file system. So we can manage the data as something model. For example, in case of a relational database, it's a table. So we put the data as the lead. Then this data structure will be managed by the specific DBMS, like the Oracle information. Then we need to have the application program to access this one. In case of RDBMS, we need to use the SQL. SQL is the only way to access the relational database system. Then finally, return the value to the user. So this is how it works when we are using the DBMS. What about the non-DBMS? Usually, without using the DBMS, where do you manage the data? Mostly, operating system is a software. How does this operating system manage the data? It's in the memory. So memory is the most important storage and the device to understand how computer is working. So somebody said the CPU. However, CPU, can you handle the CPU? So mostly manufactured. The company design the something operation, which is called as instruction. Then provide. So we can use that computational device for our computer system. So there's not much flexibility to change or the use. You need to just follow the instruction design. Okay, that is mostly assembly language. Then, however, I have the data and the information that should be searched, that should be processed. So where are they? Such a data is in the memory. Okay, so think about your program language. So C program Java. Let's think about the Java. So Java consists of a number of classes. It's a bytecode that when you start your Java application, so that class file, what happens? Will be loaded into the memory. So it's in the memory. So then you can instantiate something other class. Some of the data are in primitive, the data type, like the character or the number integer. That has their own location in the memory with address. But mostly Java manage the data as an object you need to instantiate based on the class. Then it will be instantiated using new operation. Then this one will return what? Address of this one, which is called reference. So this one, the return reference, then using that reference, the user is able to access the data. This is how it works. It's a memory-based data management. The most of the case, we can use the memory to manage the data because it's a fact. And if you understand, that is the reason actually the understanding. So think about the CS101 and 102 introduction to computing. You probably took such a class in your undergraduate, right? Freshman level. So what do you learn in such an introductory class of computer science? Is it program language? Yes. So for example, UB offered the CS11 based on Java. So they are using the Java. However, main objective of CS11 was such an introductory class is not knowing or learning such a program language. That is the secondary. You need to understand how computer is working. It's an introduction to computing, not introduction to program language. Program language is the tool to understand the computer data structure. Then, many of the instructors actually, they do not know because it is true. Such an introductory class usually taught by some of the students who graduate and they are very good at the program language. or the full-time professor, they don't want to teach such a thing. So they teach very well for the programming part, but sometimes they forget to introduce data structure, especially memory part, to the student. So that is the reason somebody says C or C++ is better to teach the CS11 and 102 introductory level 1. You can clearly use the pointer. Somebody said define the memory is what? Set of address. Okay, that is a key part to understand the memory, because depending on how to use that address, byte by byte, little endian, big endian, or how the word, what is the word, and what is the data type, and so on. So address. So without understanding address, so program language itself, why is it changing to the Python? You need to learn, okay. And what about the future? Ruby, what is the future language? You need to learn on it. However, if you understand that the mechanism, data structure, and the memory, how the computer manage and store, and the manipulate the data and the memory. So it's just slightly different. So getting easier. So human perception, higher level. Okay, but behind as a computer science. If you are not in the computer science, you don't have to worry about too much. But if you are in computer science, you need to understand this one. Go back to our main topic. So in non-DBMS, we are going to use the memory. Okay, to keep that. It's a memory-based data management. Unfortunately, memory is not big enough mostly. Even though nowadays it's several gigabytes of the memory, but still that's not enough to keep all my data. My personal data is 1 terabyte, for example, something like that. So we cannot use only the memory. Instead, we are going to use the file system. So at that time we can use the file. So for example, in our programming, so A the foo.txt file. In the foo.txt file, we manage the read. So how to access the data? Open the file, read the data to the memory always first. Then our program process instruction from the CPU can read the data and return back to the user, something like that. However, this one, you need to make the database programming. If you remind what you learned in your database class, there's a problem always. Program language is not get along with the SQL. SQL and the program language it's like the oil and the water. It cannot be mixed. Why? They have different data structure to manage the data. Relational database consider data as a group. Okay, it's a group of data. On the other hand, the program language is based on this one. So memory each instance, not as a group. So that is hugely different. So we need to use the SQL and then SQL database engine, query processing, query optimizer, then the final read the data, return back to the memory buffer. Buffer management also important one. Overall process is slow. So using DBMS is actually much slower than this one. Okay. So nobody use this if really slow. So DBMS vendor, they try to speed up this one. First approach is buffer, the cache. So this approach has been used a lot in computer history. Okay, so memory is in between the file system and CPU. In the memory and the CPU, we have cache. Even inside the CPU, we have L3 cache, L2 cache, L1 cache, different layer of cache. We use a lot of such a cache. Why? What is a cache? Why don't we reuse? So my student file is in the cabinet. Okay? So how can I get the student file? Ask the secretary. Secretary find your file. Then pick up the file and bring and send it back to my mailbox. Then I get. Will take a time. Instead, if the one student keep coming to my office, I have the copy of his or her file on my desk. Then reuse. I don't have to ask to my secretary. That will be fast. That is a cache idea of cache. But I cannot keep all the copy of all student, right? Because it's too many. So only frequent the coming student file I can copy. That is a cache. Okay, so one way to speed up such a DBMS approach is a buffer. Okay. Another, index. So we mostly discuss about how the relational database model is organized, like the table. Table has number of attributes. So we focus on, in terms of design, which attribute will be selected and which attribute it will be primary key, which attribute will be foreign key, and so on, right? But accessing the data from the table using the select from where is still slow. Even though we are using this one, like the buffer is after selection, but when you select the data like the 1 million of the data here, fortunately this data is ordered by the primary key I. How can you access the data? If data is ordered, sorted by the key, how can you search? Using binary search. If you remember your data structure class CS1 or 2, you learned about the binary search. So binary search is in terms of big notation, what is the complexity? Log n. So huge benefit compared to the linear O of n. The O of n is like this one. The more data you have, the longer time it takes to retrieve the data. O of log n is like this one. Huge benefit. But in database, even log n, no, it's not acceptable. Why? The more data you have, eventually it will take a time still. So log n is much better than the linear complexity. Definitely cannot be compared with the quadratic. Okay, n squared. N squared is really exponential. Exponential, it will not be accepted. But the log n is better than the n, but still. So we need another data structure to speed up. The binary search is this one. Binary idea of a binary search, cut in half, cut in half, cut in half. But it's still slow when you have the really very large data. So you can construct another data structure that is indexing. There are different ways of indexing. The relational database use mostly what kind of indexing structure? Do you remember that? One of the most popular indexing structure. Tree. What kind of tree? Binary tree. That is a mistake. So actually, think about that. If you build a binary tree, how many nodes do you have? It's really a lot. So binary tree is one of the simplest tree structure. Instead, B tree or B plus tree. The B, if you remind the B stands for not binary. It's a balanced. Why do we need a balanced tree? So once again, binary tree is like this. The value less than this one, pointer. So only two branches, children node. So when you have the huge number of data, it will be really huge. The problem is how many layers. That determines log n. It will be huge. So binary is not practical in our database, relational database system. Instead, it has number of nodes. At the node, we have number of the item inside. So it's not binary. Instead, it's a tree, general tree structure actually, like this. It's a tree structure. But it's not general tree. Problem is when data is skewed. What does that mean, skewed data tree? It's not balanced. Do you remember? It's one of the popular questions in your data structure class. What if the tree is really unbalanced like this? This is the same as what?
Linear.
Linear, linked list. So if data is skewed, this one definitely slower than this. You cannot get the benefit of logarithm. So what we need is balanced. Another reason to be balanced tree, to make the balanced tree is it should be predictable. Predictable means that's the third one. Optimizer. So optimizer. I always use this example to explain what is the optimizer, how it works. So think about I have an interview tomorrow at Manhattan, one of the companies. Okay? What is the most important thing when you prepare the interview at Manhattan? You should arrive on time, right? So if you are rich, you can book a hotel in Manhattan, so you can stay one night. But mostly you will travel. So what is the best way? Which one is better, fastest way or the reliable way? Reliable. Even though it takes 2 hours, so if every time 99% of 2 hours, I'd like to take that one, like the MTA. Driving, sometimes fast, sometimes if you get stuck. Okay? In the 95, usually in the morning, it will take much longer time. If you are lucky, less than 1 hour. But if you are not lucky, so 2 hours, 3 hours. So it's unbalanced. So to decide the really fast way, what I want is the guaranteed time. It's a kind of real-time operating system, real-time processing. It's a guaranteed time. So database, when optimizer decide the way, there are a bunch of different ways to go to the Manhattan. Like to think about MTA, the bus. If you are super rich, the private jet from the New Haven airport, or the motorcycle, and drive, the Uber, others. You can walk or run. So there are a bunch of different ways. Even if you travel 2, 3 multiple cities, multiple visiting, it will be really exponentially increase the different cases. You need to select what fastest way. And that should be reliable. When I select that, it should be that time. So optimizer, your optimizer is doing such a selection of which way is the fastest way. Okay? At that time, we need reliable, the time that balanced tree provide how many level? If balanced, always same level. Okay? Same time. If non-balanced, like this, sometimes fast, sometimes slow, sometimes fast. So this cannot be used. So we always want such a balanced tree, B tree or B plus tree. That is not the binary tree. So sometimes I'm asking the advanced database student to implement the B tree or B plus tree. So surprisingly, half of the student use just a binary tree. One reason, very easy to find the source code of the binary tree, and they're simple. But B plus tree, you cannot find many, such as the well implemented source. But 99% of the indexing used in the relational database management system is based on the B plus tree. So, plus something other. Nowadays, the index organized table, or something memory-based database. So, not only just using buffer, why don't we create a table on the memory? The problem is, memory is volatile. It's not reliable. Without power, you may lose the data. Then we can consider something other way. The UPS system, like the power, keep providing the power even though something happened, or fast nowadays non-volatile memory, like the NAND memory, like your flash drive. So we can use such a technology to speed up. So this is the relational database approach. Then it will be faster than this. Because of these characteristics, it will be expensive when you project. Think about the Oracle. Actually, Oracle is one of the most expensive one. And more important thing is you need to pay every year. So like I got the finally approved by the executive level. So we got the Oracle database, for example, like the $100,000. Every year you need to pay 20 to 25% of your purchasing the price for maintenance fee, even though you don't get any service. That is a huge maintenance fee is really high. And also you need to hire, because I do not know anything about the complicated software. You need to hire the administrator who is in charge of to manage the DBMS. Why? It's not only just the knowledge of database itself, it requires experience. Mostly asked question by the developer in your department, in your project, to the database administrator is, can you guess what is the most frequently asked question? Very slow, always slow. So I developed the query and database program, and I submit it. It's slow. It's your problem, not my problem. Okay? Why don't you make the index? So you can add the index. Then it's getting slow, really. If your design, database design is perfect, ideally, then you need only one index for primary. Primary key is the only way to access the data, and fastest way. Sometimes you can use a candidate key. However, your database is not like that. So, like the 2,000, 3,000 different entities, so sometimes it can be merged for what? Denormalization. So, denormalization, sometimes normalization is a split to avoid any redundant information. But to access two different data sources, it will take a time. So why don't we merge? Even though it's disobey, okay, disobey the idea of normalization, idea of database design, just merge for speed, to speed up. At that time, the primary key is not the only way. So you need to access the data using attribute B, attribute C, other attribute. Then to speed up, why don't you create the index? So this is a main table. So this is a primary key. It's a column A, B, C. So index for A, index A. Index for B, index for C. Which means you are going to manage different files for index. Then what happens? Whenever you insert the data, you need to update this one, this one, this one. It's not just updating. You need to sort the data. Sorting is the most expensive operation in any computer system. So it will take a really long time. So finally it will be mastered. So you cannot accept, approve all their requests every time. So always decline. Then you need to show how you can avoid. So you can, that is a SQL tuning, like by changing the order of the table, or by using the hint. Hint is the kind of the hint of query optimizer, because this guy is kind of the intelligent system to find the fastest way. It's from my old university to donate the money. Always this time they call. Between 7 and 8. So because I got the phone call last time, so after that they realized that it's a really a live number. Keep calling. Okay, so where am I? So for the index part. So index, so you cannot get. So you need to, you can the speed up actually by changing, by understanding your SQL, then using hint. Hint is to help. Optimizer is not always perfect. Nowadays it's getting better, but still 80–90% are good, but the other 10% you need to manually to specify how to access the data. So like not always Google Navigator is the fastest way. Sometimes you know this one and this one, so that will be faster. So something like that. That is called a hint. So you can use such a hint or help your query, then you can speed up your query. So that is the database administrator job, which means you need experience, really experience. Not just the skill, but experience. So that spend a lot of money. So because of that, you cannot always use this one. Instead, at the time you can use this. How can I manage the consistency? Database provides very, very strong consistency. But what about this one? You can do that in your program level. And also you can keep any other constraint, like the primary key constraint for it. You can do the same thing in your program level. But your programming will be more complicated. Also need plus maintenance later. Okay? But considering overall cost of this one may work. Okay? So this is the relational, the overview of the relational database focusing on the RDBMS system. Okay? So today we are going to see such a summary based on that idea I'd like to introduce. Mostly, if you already know what the basic thing, I'm going to skip, but try to give something in mind, as well as you're able to point out the key point for to understand the NoSQL database later. So this is a database. So what is a database? Still, my definition of a database is being changed. So, but in general, we can say the database is a collection of data. But the database itself is kind of a data structure to keep the bunch of data. So, from always I highlight the importance of the data structure. So, that is because of the nature of the computer. Computer is totally different from the brain. Okay, so I do not know much about them. I'm not a neuroscience scientist or whatever, but computer is different from what human being is doing. So to address that, to bridge the gap, we are going to use such a data structure. So it is important. So if you have a chance to teach CS101 introductory level class, so like if you are holding the master degree, you are able to teach, okay? Same level or the low level, which means BS or the master level class. So if you have a chance to teach introductory level of computer science, always start with what is the most important part, do you think, when you teach the computer science to the beginner?
The architecture.
Architecture? Any other? OS, operating system.
Memory.
Memory, component, like the hardware component. I think the most important part is the binary system. So they should understand, even the instructor should know the binary system. It is true, electronic device start from the 0 or 1. Okay? We don't have to teach like the electrical engineering guys. Okay? We are not in the electrical engineering, but it is true. Our computer, definition of computer, what I mentioned about this, the thing to compute. We had a computer long time before abacus and the Leibniz style the computer without power, without electron. So when we are saying the computer is an electronic device, that is based on 0 or 1. Turn it on, turn it off. So electronic, what does electronic mean? It's a circuit. Why is it called a circuit? It's a circular. Circular of what? Current. So power is actually power of current. Okay? Current is not like the plus to minus, it's minus to plus. Then if you hold the current, what happens? Then it's the resistance. Then it will be like this one. Like that. Depending on the sensor. Okay? So we can handle such a current to represent 0 or 1. Based on that idea, we can develop vacuum tube. So vacuum tube can represent 0 or 1. Then by combining 8 vacuum tube, we can represent 2 to the power of 8 different number in terms of binary. Then if we code like the 0, 0, 0, 0, 0, 0, it means 8. Then 0, 0, 0, 0, 0, 0, 0, 1 is a B. Then we can represent alphabet, that is ASCII code. And number. So right now we are ready to represent alphabet and number. Then we can do whatever we want. Right? So binary system is, I think, the most important one. If your student can understand binary system, I'm teaching the CS 101 and 102 in China during the winter break. So at that time, I'm doing the kind of game. So I select the 2 teams. Each team has a 10 member. Then the 8 of them here are each team has I think around 20. So like an 8 member. Then there's one coder and another one is a decoder. Then the handout, the ASCII code table. Then first explain the binary system and ASCII code. Then why don't you send this letter? Then each student here is a sender. The A student has to hold 0 or 1. I ask to use the cell phone. Light on, light off. So light on means 1, light off is 0. So for example, if Lee is 0, 0, 0, 1, 1, 0, 1, 1. I'm not sure whether this is true or not. Anyway, then the L, the decode, encode, right? Encode using the ASCII table, and this guy assign 0, 0, 0, 1, 1. Then at the same time, they either turn it on or off. Then they receive like this. Then they will get 0, 0, 0, 1, 1, 1. Then give what they receive through the light. Then this guy will decode. So from this one, using ASCII table, this is L. The next letter, E, LE, then they can send the data. So this is a bus, right? So this is each of them is a vacuum tube transistor. Okay. By combining all of this, this will be IC, VLSI, and the wiper. This is called the wiper, whatever. So this is how it works in the computer system. Okay. exactly same in the like the 8-bit, the 16-bit the computing system. Then if we transfer from the memory here, so if we ask like if we have the grid side such the block or the whatever, then we put the data and ask the address of this one, the send and get the like the command, like the bytecode in the instruction letter. So I'm starting the such a CS11 class is the pain. Some first time they do not know what they are doing. Okay, and everybody knows the binary number, binary system. Then the key part of this one is how computer is organized. It's actually based on the binary system and so on. So database to organize such a very large data, we may need different data structure, that is the database and the database model. So then, so it doesn't have to be only alphanumeric data. Like sometimes database has the data from the Word document, sometimes the images, sometimes the video file. It's a variety of the data type. Okay. However, relational database focus on alphanumeric data. So that is because the characteristic of the modeling. So if you go back to the fundamental of the relational database and their modeling, we start from entity relationship. So entity is the something and defined by the attribute. Then we select the key attribute. Then eventually there will be table and the primary key, and but we limit a lot of conditions, like each value should be atomic, or this should be unique and non-null as a primary key, and so on. Because of that, only alphanumeric, alphabet or numeric data can be atomic data. But if we have images, in terms of the ER modeling, it's not easy to model. So we can model the metadata, okay? But we cannot model the pixel by pixel semantic of that. So it doesn't make sense. The relational database can support fully imaging. So we need to think about the different database, image database or video database. So that is the database. Then, if we have such a model, we are going to use such a model. How can we use? Implementation. We need to implement. That is the RDBMS. So RDBMS totally depend on the database model. If that is based on the relational model, we call the RDBMS. If that is based on the hierarchical database model, we call hierarchical database management system. If that is based on the object-oriented concept, some of couple of students, I think, selected the object-based NoSQL database. Actually, relational database cannot support object-oriented database. It's a different one. Main idea is to represent each data item. Relational database use key, primary key value. Eventually, that will be row ID. I will introduce briefly later, but it's a row ID. But object-oriented concept, object-oriented database is a object ID. So you should have the object ID. So relational database cannot represent such an object ID. So it's a different one. So based on that model, there are a variety of the RDBMS. We are going to focus on this relational database model. Then, what is the difference between search and query? So when you find the information about the Professor Lee from the Google, we are saying, we are searching the Google for keyword Lee, Professor Lee, something like that. We do not say, I'd like to query Google. Nobody say. But when you search when you retrieve the data regarding to the Professor Lee from the UB database. We are saying, sometimes we are saying search, but in the class mostly we say query the data. Okay? So what is the difference? The search is mostly based on the grep command. Have you ever used the grep command in Unix system? This is the retrieve, the line that include the keyword. Long time ago, when I think in this class I probably mentioned, when Jerium developed Yahoo or Google, they actually first time used the grep command to find the one record, one line that includes the specific. So actually they do not use any data structure that we have discussed a lot. So at that time we called the search activity function as a search. On the other hand, if we try to use such a model, different data structure to keep the database, at that time, we need to follow that model. Okay? If we are going to search the data from the relational database model, we need to use that the way of how data is organized. The data is in the table. Table is consists of number of attributes. We need to use such exactly same way. If data index, we need to use the index. At that time, we called such a functionality as the query. So what we are interested in this class is NoSQL database or the relational database query. Okay, not the search. However, information retrieval. So nowadays, many of the database class include information retrieval also, like the Google search, web search. So such a functionality, searching functionality are getting popular also. So NoSQL database even support such a search. So if you are taking the big data system, it's kind of in between. It's not clearly the query, the data from big data system. It's a kind of search. Then there are software, the program that can help speed up the search. But they are sometimes structured using NoSQL database. So it's kind of in between. So NoSQL database, sometimes query, sometimes search. If we are using the query, we need to follow such a data structure, which means it's not flexible. It's a structure. And this reason SQL is called a structured query language. We just follow the way of organizing data. That's the query. But NoSQL database doesn't like such a very strong the structure pursuing the flexibility. So it's hard. So some of the one of the characteristics of NoSQL database that we discussed, they are not using SQL, right? Because it's too strict. So instead, they try to use the API level or others. So it's kind of in between. And the search and the query in NoSQL database. I already introduced such a memory. It's based on the memory. It is true. You can see nowadays a lot of database system, even NoSQL database, is memory based. They try to bring up the data structure into the memory. So what is the difference between the memory based and the file system based database? What will be the main difference?
The one that uses memory keep more of the data and memory than.
Then to do that, speed definitely. File system, we rely on file system data structure. So we can use the file as a table. Even if we don't want to use the file system, at least raw device. Raw device means just the hardware, your file system. So when you purchase the hard disk drive itself is the hardware media. Old-fashioned the hard disk drive is you can find the disk, then the disk. To introduce also disk, you can use the binary system. When you write, have you ever used the CD-ROM or the DVD to keep the music or file or the such of information? If yes, you are a little bit older. Nowadays, nobody uses. But in my case, so I purchased the write-over CD, write-over the DVD still. If you go to the Walmart, you can find, but nobody purchased it right now. But so how does it work? Actually, it's very simple. Write-over device, you can make the hole or close it. If you make the hole, that is 1, close, 0. You can represent 0 or 1. Then you can write any structured data, like this. Okay? So that is 0 or 1. Then that is how it works in the file system. So you can rely on the file system. Is it the same in the memory? Can you use the file system in the memory? No. Instead, it has only the address. It's like when the government developed the new town and new city and the new development. What is the first thing they need to do? Measure everything, then decide this is the road and the side road, and assign this is the zone for the residential area, this is the commercial area, and then assign the zip code and the address. And nothing there, it's just the address only. So you need to use directly address. So many of the case you can use the system library like the shared memory, just like the shared memory gap or envelope. So you can use the envelope or the memory map file. So you can create such an area. Problem, like the security, protection. If you are using the file system, it's a file system support. So you can use such a benefit. Memory, nothing. So you need to implement such a new data structure that feasible to the memory. That is the memory-based the database nowadays. If you already select the memory-based NoSQL database, think about such a different thing, how they are working. Not just fast, okay? Instead, how they implement, how to address the security issue or something, the persistent, the data, how can they keep. Okay, then finally, we can have the database RDBMS system. And what's the difference? They provide such a thing. So I already mentioned about the fast, very efficient. And other thing is other benefit of the concurrence control. We talked about the consistency a lot the last time. What is the concurrency? Together, multiple transaction. So multi-user. If we have only one user in the system, not only database, any system will be very simple. Okay, we don't have to worry about too much. But problem always happen. Many user, the process are accessing the same data. That causes the what? Racing issue. If you remember the operating system. So racing problem is shared data accessed by the many processes. So that is a racing, compete each other. That causes the what? Synchronization problem, eventually deadlock problem. Deadlock is critical in computer system. That happens in the database management system also. So database management system addresses such a problem, deadlock. For example, if you remind what you learned in your advanced database class, you can for the concurrence control transaction. Then transaction, number of transactions should be scheduled, serializable the scheduling. Then that serializable is not the simple serialization like the A transaction, then B transaction. No, then it will be slow. You can allow multiple transactions same time, but it looks like the one transaction may have number of operation, read and write operation, group of read and write. And another transaction, read and write. We are going to make the serialized. That is called equivalent. By changing the order, assign the order of read and write from the multiple transaction, it looks like the serializable, the schedule. So that is the one way to keep the concurrency control. So really complicated, not really, but it's complicated. So for example, Microsoft SQL Server, actually it was not the multiple transaction. There was no concurrency control first version. Why? Just like the operating system, Microsoft Windows. It's a personal purpose. Windows 3.1, 95, and 98, up to 98, is a single user system. Then from Windows NT, it supports multiple user, which means you are able to log in and multiple users are logged in. The same operating system, they can do their job for each job. Then at the time, the Microsoft realized database should be also multiple user system. That means concurrency control should be implemented. They decide to purchase, to buy the concurrency control module from the Sybase. So currently, probably it's changed a lot. The first version of the SQL Server used the Sybase, such a multiple the transaction management. That is for the concurrency control. Recovery means one of the important thing of the ACID. Do you remember the ACID that we discussed? Last one is the D. D means durable. Durable means once commit. Once the transaction is done, no matter what happens, that should be always permanently. Okay? How can you keep such a durability in the database system? That's one of the way is the recovery. Recovery is not always a huge problem. Recovery. Sometimes one transaction failure, that should be recoverable. If I commit, but that transaction something happened, that should be recoverable. So recovery should be supported by the RDBMS also. A lot of things. Okay. So we already talked about such a thing. You can see the number of slides is 187. We are but we talk about a lot of people. Do you remember the diagram? This is called. Anyone who took the database design? And this is how many levels? 1, 2, 3. 3 schema architecture. This is NC standard, this is American standard, industry, whatever. So database should support these 3 different schema architecture. Mostly when we design the database, that is a conceptual schema. That doesn't mean we know where the table is created, how table is using the file system or memory. That is a physical schema, internal view. Okay? Then who is in charge of such an internal view, physical schema? RDBMS actually should implement such a thing and the different view to support the concurrency control and consistency. So it allows the multiple user, multiple different view, but it still actually access one schema. So this is actually view object in database. Like the create, you can create a view of what? It's a virtual table. So overall, this is called the abstraction. So RDBMS database, the relational database support a lot of such an abstraction level. What is the benefit of abstraction?
On the layer can change without the
You don't have to worry about it. Yeah. Only you can focus on the interface, in and out. So that is abstraction because of the if you are using file system, I mentioned, you can do the same thing. How? In your application program. This is not abstract. There is no abstraction, which means you need to do everything. Complicated. If the business logic is very high complex, it will be really high maintenance, the effort. So, database provide a very high abstraction level, which means sometimes there is a new column. So we add a new column to the employee table. Why I need to change my program? You don't have to. Because there is an abstraction level. So what I need to do is access the salary of employee. That's it. But if you change this file system for employee, you need to change your program. That is abstraction. Different level of abstraction. Like this one. We don't know. We don't have to worry about where the table is created and managed. Instead, just focusing on the schema diagram. So that is abstraction. That is a benefit of using the database. I don't have to explain this one again. So, but this is a main characteristic of the RDBMS. Special Relational Database Management System support very strongly this one. Specifically, all of them. Like the A atomistic is for the transaction. Isolation is also concurrency control, transaction management. Durability is a recovery and transaction. But most importantly, the consistency is the one of the reasons why relational database is still the top database model to be used. So to understand the NoSQL database cannot keep such the ACID property of the transaction. Instead, we need to sacrifice the sum of them. So that is the starting point of that. Then, as we discussed last class, NoSQL still is good, right? It's a really strong property, but it's still good. I'd like to keep the consistency, and I'd like to keep the availability. Even the distributed data. So, can we make them? Actually, theoretically, it's not possible, but we can work around, we can get in close. So that is the idea of a NoSQL database, such as the spanner and this one. I think that some of you selected the NoSQL database. Actually, this support the NoSQL database. You can present such a characteristic on your the page 2 writing on. Okay. Okay, so let me stop here. We are going to have the 10-minute break. So I'm going to resume 8:30. I'm not 8:30, 7:30. Okay.